All right, so welcome everyone to another Sunday morning meditation, 9 a.m. maths session. So today we are going to do a very interesting topic, which is not difficult at all, right? But if you understood that in the right fashion, it is one of the easiest topics to deal with. And that topic is called trigonometry. Now, what before we really deep dive into trigonometry and its questions, let's first understand where exactly trigonometry came from, right? So roughly around maybe 4,000 years ago, roughly I should say, people wanted to measure things which they could not physically reach. So for example, top of the mountain, uh, maybe to another the distance of another planet from Earth, and so on, right? The height of the pyramid, right, which is from the ground. So they are all literally very huge distances to measure, and obviously they can't build that big a ladder, right? So they invented something called angles instead of measuring the distances. So that's how angles came into picture, right? And then there were various civilizations in past, like Babylonians, Greeks, and then Indian mathematicians and the Arab mathematicians, which eventually did a lot of work on these angle measurements and even further developed mathematics. And that's where trigonometry sort of evolved. Now, roughly around 6th century BC, so there's a story behind 6th century BCE, there was a Greek philosopher called Pythagoras. So Pythagoras developed the very famous theorem that we still use, which is Pythagoras theorem. And we will do that today a bit before we actually do deep dive into trigonometry. Now, Pythagoras was particularly interested in right angle triangles. So, right angle triangle is the angle triangle. We did that, you know, 2 sessions back, where one of the angles is 90 degrees. And then he studied the relationship between the sides of those right angle triangles. And then later, Greek and Arab mathematicians, they picked up this Pythagoras theorem and mixed up the trigonometric ratios with it, which we will going to learn, the sine, cos, and tan. And they started measuring large distances with the help of Pythagoras theorem. And obviously, trigonometry is not just restricted to the Pythagoras theorem and right angle triangle. It can be applied on any kind of triangle, right? But particularly, the learning of trigonometry starts with applying it on a right angle triangle. And that's how trigonometry became a very primary tool, which in today's world, mathematicians, engineers use when we are working out distances from one point to the other, which are physically or practically not possible to measure. Now, whatever you see today around you, huge buildings, pyramids, bridges, ships, etc., whatever you see, which is huge, they are all because of geometry and hence trigonometry that exists in mathematics. Now, the word trigonometry, if I just write it down, the word trigonometry, trigno, trig, no, trigonometry is divided into two parts. Trigono means the triangle. And mitri is nothing but it's metron. They all come from, they're Greek words. They're Greek words. So this is triangle, or we call it as trigonon. So trigonon became triangle and metron became metri of English. So they are all Greek words. So the origin of trigonometry comes from Greek. And you will see a very heavy influence of Greek letters here. The very famous of trigonometry is theta, which is very popularly used as the measure of the angle in trigonometry. It is the eighth letter of the Greek alphabet. Eighth letter. Just like we have A, B, C, D, E, F, G until Z, they have their own alphabets, and theta is very commonly used. Is most commonly used when we are measuring angles. It's just like algebra has X. We say any unknown is X. Any algebra question that you see, you will see the influence of X in it. Similarly, for the unknown, X is for the unknown, pronumeral. Similarly, in trigonometry, we use theta quite a lot for the unknown. Having said that, later down the track, when everything got mixed up, the influence of algebra also came into trigonometry, and we started calling unknown angles as X as well, right? Metron is the metri. Metron means the measurement. Measuring the triangle. Metron means measurement. So, or the measure, probably the measure. This is nothing but the measure, should I say. Measure. Measure of the triangle is what trigonometry is all about. That was a bit of a story behind trigonometry. These stories are never called, never told. And we are jumped straight into the formulas, which I don't like, till the time I don't know the why behind it. I feel it difficult to digest. So I thought probably introducing this topic and straight away throwing you all into the ocean of sine, cos, and tan. Let me just, sort of, give you a bit about what this is all about. And not sure if you have heard about, the stories behind it. Sorry, I'm just digressing from mathematics, but I feel as a student of mathematics, it is very important to understand. I hope you don't mind, right, me telling you stories today. Now, and if you have an acquaintance with trigonometry, you would have used sine, cos, and tan. We'll talk about it, right? Now, what is sine? These three are the ratios. We know that. If you don't know that, we will define what that is. Don't worry if you don't know. But if I talk about what is sine, sine is S-I-N-E, sine. It's not sin. It is sign. The S-I-G-N, the traffic sign. It's called the sign, not the sin, please. Right? Now, there's a funny sort of a historical accident behind sine as well. So the Indian mathematicians use the word jaya, right? And when they were talking about chords of the circle, What is a chord? So if I join two dots, 2 points on a circle, it's called a chord. So half a chord was they called it as JYA, yeah, and J is silent. Right? So you can pronounce. I mean, if you want to say it's Jaya, right? Jaya. Now, when it got to the Arab world, Arabs started calling it as Jiba, right? Then there was a translation error, pronunciation and translation error. Later, when it traveled to Europe, they started calling it as jibe. And then the Latins eventually even funnily translated it as sinus. And from sinus, it became sine. So there's sort of a funny incident behind what sine is and how it developed. It still talks about the measurement of the chord, half chord of a circle. Nothing to do with trigonometry, but just a story behind what this is. And then came cosine, which is cos. Now, a cosine is cos. Cosine is called complementary sine. Complementary sine. Last week, I think a week prior, we did learn what are complementary angles. Can you tell me on chat, if you remember, what are complementary angles? Quickly. Complementary angles. Exactly. They add up to one, not now 180, they add up to 90. Good. They add up to 90. So sine and cosine are complementary angles. So the complementary angle of sine eventually became cos or cosine. Not 180, it's 90 degrees. So sine 90 degrees, take away my theta. Theta is the unknown, x here is actually cos theta. They are complementary angles. And then became, so basically cosine simply means the other angle of a triangle. The complementary angle of sine is cosine. And then came tangent, or tan is what we call in today's world. Now tangent is coming from geometry straight away. Tangent is that line that touches the circle at one point. And that is where the word tangent came into existence. And hence, it has an influence in trigonometry as well, but then it became one of the ratios. Because all of that started to make sense, right? You see here. This became a right angle triangle. So this tangent started to play a role. So that's a history about how sine, cosine, and tangent came into picture. There are three more ratios which are the reciprocal ratios of trigonometry, but not that they're not required to be covered at this point. So we'll stick to sine, cos, and tan. I hope this was interesting. And with that, let's deep dive into the world of trigonometry. And we will start with Pythagoras theorem, right? which I think most of you know. Now, someone wanted me to scroll back up. Uh, don't worry, I will still share this. This whiteboard is shared in the WhatsApp group. So ask your parents, if you are not a part of that group, ask your parents to share that whiteboard with you, right? All of that is shared, and the uh, recording is also there, right? Okay. Now, I'm assuming since you are a grade 7, grade 8, maybe a grade 6, Pythagoras theorem is very, very common. But for to connect the dots properly, I will still write it down. I'm not going to prove it, and it is, it's not required, right, for us. So if I have, let's say, A, B, and C, and they have got these are small, these are the measurements of the sides of a right angle triangle. It simply tells me that C square, which is the longest side, is the sum of the squares of the two other sides of a triangle. That is nothing but, in its simplicity, what Pythagoras theorem is all about. Now, with that in mind, I want you, I mean, we will not be uh, using the calculator still. And if I now quickly ask you to calculate using Pythagoras theorem, so this is hypotenuse, and that's the base of the triangle, right? And that's the vertical, we call it as vertical. All right, cool. So if I say this is 7, this is 11, can you tell me x? Quick, now. Give me in a third form. Give me in a third form, no decimals, please. Lakshya, we are not talking about adjacents and opposites. We haven't talked about angles yet. Don't worry, we'll talk about it. And that is why I wanted to connect the dots. Trigonometry is not just about adjacents and opposites straight away. Till the time the angles are not there, there's nothing adjacent and nothing opposite. I haven't introduced angles yet. I want all of you to answer. The 35 participants here. Can I have all of you getting your hands warm up and give me the answer? Root 170 is the right answer. So what we're saying is x square is 7 square plus 11 square, 49 plus 121 makes it 170. X is root 70. Good. Next bit. I've got a triangle. Problem. Why not I take a snippy of it? Let me take a snippy. All right, here you go. Can you find me x? Go for it. Root 132 is what I'm hearing. Sorry, I'm looking. My bad. Root 132. Anyone who hasn't got that answer? Root 132 is the right answer. Good. Root 132. And how do we get there? This is hypotenuse. 14 square equals to x square plus 8 square. And 14 square is 196. X square plus 64. X square is 196. Take away 64, which is 132. So your x is a root of 132. Now I'm doing it at a pace because we've done all of that is needed, right? Linear equations, etc., etc. All the dots have been joined. So if you don't understand what I've done here, how I've solved here, I will highly recommend you go back and watch the playlist that's on video, that's on YouTube right now. It has got 17 videos there. Today is the 18th session, right? All 17 videos are there on the YouTube playlist, right from the day when we started. All right, cool. That makes sense. All right, now that was a bit about Pythagoras theorem. Let's maybe sort of try to do one another question and see where you land, right? Okay. I'm going to write a question now, and it's a worded problem, and I want you to solve that. And I'm taking a snippy of that. And all of this has been taught to you in the last 17 sessions. There's no figure given to you now. There's only words. There are only words. And I want you to give it a go. Sorry. Let's see where you land. And I just need the answer in no decimals, right? If there are decimals, just give me surds. Millimeters is very important to be added to your answer. If you don't add millimeters, and this is not for your selective school exam because obviously that's a multiple choice. This is an advice for life, right? Especially until year 12, if you've got maths by that time. When there are worded problems, there are units attached to every number. So you need to answer the question with units. All right, 12 is the right answer. 12 millimeter is the right answer. Now let's see how we arrive at that answer at the very first place. I have talked about all of that in my previous sessions. It says calculate the perpendicular height of an isosceles triangle. Let me first draw an isosceles. Can someone tell me what is an isosceles triangle? Hang on, don't tell me. I'll let you know. Isosceles triangle is that triangle where two sides are equal, right? It's with equal sides, two sides. And so this is 15 millimeter. This is also 15 millimeter. So they are equal. And I said, I will just write these small. I just cut these lines like that, right? This just tells me in the world of geometry, that these two are equal. And it says calculate the perpendicular height. So I need to calculate this height h. Now, whenever you have an isosceles triangle and you draw a line perpendicular to the third side, it cuts this into two equal parts. You see now, I've just put two lines here and here. So that tells me that these lengths are equal, right? And the third side was 18, so this must be 9. And the word perpendicular tells me that it is making a 90-degree angle on the side where it is making that perpendicular. So eventually this question reduces down to a right angle triangle where this is 9 mm, this is 15 mm, and I just need to find h. Now you can do it. Using trigonometry, you can simply find this to be 12 mm. If I would have given you this problem straight away, you would have taken a minute, less than a minute or under to solve me. But the moment I gave you this, half of you fell flat. Didn't make any sense to you. Problem solving is very, very important, right? Oh, good, cool. I hope, is this clear to everyone what I've just done here? Is this clear, everyone? There are 35 or 36, right? We're down on numbers today. We are normally around 40, 45. Okay, good. Now, if I ask you now, okay, so I'll just change the color. And now you know that this height here is 9. 9, sorry, 12. And now if I ask you, can you calculate the area of this triangle? Go for it. Area of the triangle now. How on earth are we 54? Come on, what are we doing, right? $108 triangles. Which triangle? Come on, this triangle. Is everyone able to see this triangle that I've just circled here? This triangle, I need the area. What is the area of triangle? Half base times height. My base is not 9. My base is 18. 9 and 9. Half times 18 times 9. Oh, so 18 times 12. The height. That's not 216. That is 108 square millimeters. This is very important. I'm talking about the area, square millimeters or millimeter square. Or you can write it like this, millimeter square. Is this clear, everyone? See, we all are very eager to solve, get into the world of trigonometry. It requires a very strong grip on geometry, isosceles triangles, complementary angles, and we'll further down the track, we'll see alternate angles, vertically opposite angles, all of that we've done. And the lessons that I've done prior were required before we jump in here. All right, cool. Now, let's talk business. Let's talk about the right angle triangle and the angles with it, right? Now, I have a right angle triangle with one angle as 90 degrees. That is why it is right angle triangle, right? Let this angle be theta. Of since you won't have theta in your keyboard, let's call it as x. Now, can you tell me the measurement of this angle? What is this angle? The one that I've just marked. What is this angle? If that's 90, that's x. What's this angle? I want you to put your brain on it. Give me this angle in terms of x. In terms of x. I did not say 45. I did not mention anything here. That's x, not 45. Yes, Karthiki is right. 90 take away x. Neeravi is right. Good. Shaban is right as well. So, oops, sorry. This this angle is 90 minus x. 90 minus x. Now let's mix angles and sides and see what we churn out of it. Right. I am just taking off this for now, and we just concentrate on x at the moment. I'm not calling it as theta, right? Because it will be difficult for you to write it down. Yeah, 180 minus 90 minus x is 90 minus x. Exactly. All right, now the triangle has three sides. The right angle triangle also has three sides because it's a triangle. But these three sides are called by specific names in the world of trigonometry. The longest side is the hypotenuse, the h, hypotenuse. I could be wrong in my spellings, pardon me for that. And I call it as h. Now, depending on the angle that I am considering, other than the right angle, I've picked up this angle x here. Now, with respect to this angle x, there are two more sides. One side, which is bang opposite to it, is called the opposite. And I call it as O. And the other side, it's just sitting next to it, adjacent to it, is the adjacent. Or I call it as A. Now, let's change the reference point of this angle. And I change the color of my pen. Now, let's talk about this angle. And this angle is 90 minus x. You remember that? Now, let's work out the sides again with respect to this 90 minus x, the green angle. Stop chattering on chat. You're disturbing me. Right? Something really serious is going on. All right, and we still have people joining. Stop giving reactions, guys. You're just disturbing me. All right, now 90 minus x. We talk about this one. The hypotenuse is the longest side. The angle, shifting the angle, whether I'm talking about this x or 90 minus x, doesn't change the reality. H remains h. But what it does change is the position of the opposite and the adjacent. The opposite of this 90 minus x, hang on, is this side. So now this side becomes opposite, the O. And the side next to it now becomes the adjacent, the A. So the moment I shift my angle, hypotenuse remains the same. It's just the adjacent and the opposites that change. Now, let's do a little exercise and try to find what's an adjacent, what's an opposite for two given angles. So I'm just going to draw a picture, another triangle now. And let's say I call this as A, this is B, this is C. They are the measures of the sides. Okay. My angle is X. Can you tell me what are the opposite for X? What is the opposite of X? One person should be just typing once, right? I'm just looking at the chat. Yes, that's the opposite. Now, if I change this X, yeah, what is my opposite now? Exactly. B is my opposite. Not AB, it's just B. Someone wrote AB. No, it's just B. Right? So this becomes my opposite. My hypotenuse does not change at all. Now, so we learned what is hypotenuse, what is opposite, and what is adjacent. Let's try to fit in trigonometry, the sine, the cos, and the tan in the overall picture. When Pythagoras' theorem was invented by the mathematicians, and the sine, cos, and tan also existed, then they applied this and they found that the sine, cos, and tan eventually serves as the ratio of the angles, sorry, ratio of the sides of a triangle. They end up becoming the ratio of also the ratio of the sides of the triangle. Now, how are these ratios defined? Is you've heard so ka toa. If you haven't heard this, hear it out for the very first time. So ka toa. The so ka toa, the first word of every three-letter word, is the ratio itself. S is the sine. C is the cos. T is the tan. And O and H are the opposite and hypotenuse. So it tells me sine theta is the opposite over hypotenuse. Now, depending upon where my theta is, the opposites and the adjacents can change. Cos theta is adjacent over hypotenuse. And tan theta is opposite over adjacent. So these are the broad definitions of sine, cos, and tan. All good? Now let's do a question. Aradhana, don't worry. We'll do a question and that'll make more sense. Right? Don't worry about it. Let's do a question. I'll do a question and explain you how it works. This is a right angle triangle. And my angle is x or theta, if you want to. Let's say x. And let's say this is 5, 3, and 4. Now, this Let's first thing we need to work out our hypotenuse, opposites, and adjacents. Hypotenuse does not change, it's the longest. This side becomes the opposite, and this side becomes the adjacent to the x. Now, if I'm asked what is sine x, so S-O-H, opposite over hypotenuse. So, which essentially means opposite is 4 and hypotenuse is 5. So, sine is this bit. It picks up these two sides. Cos x is ka, which is adjacent over hypotenuse. Adjacent is 3, hypotenuse is 5. Adjacent is 3, opposite is 5. 3 on 5. So I'm picking up this side of the triangle. This basically this block of the triangle. So we've covered this, The only thing left is this, which is the tan theta. Which is 2r, which is opposite over adjacent. In this scenario, it is 4 on 5. So 4 on, what was this? 3, right? 4 on 3. So that is sine, cos, and tan. Sine is so, it's opposite over hypotenuse, which is 4 on 5. Cos is ka, adjacent over hypotenuse, which is everyone able to hear me loud and clear, right? My internet is rock solid at the moment. Cool. All right. Time to send a few people out of the classroom today. My apologies. Right. So, yeah, in the very next opportunity, you know, 2 students will be sent out. They've distracted me enough today. Once I finish this up. So we understood sine, cos, and tan. Now I'm giving you another same question, and I say 5, 3, and 4, and my angle changes. This is my x. Can you work out sine, cos, and tan for me? One student has been sent into the waiting room now for the very first time, and I just word of caution to the others. All right, let's talk about it. That's my hypotenuse, that's my opposite, and that's my adjacent, because this is x, opposite and adjacent. So, ka tua. So is sine x is opposite, opposite is 3 over 5. Cos x is adjacent, 4 on 5. And tan x is 3 on 4. Good job, everyone. Is that clear? Everyone, is that clear now? Good. All right. Now, let me just take a snippy of it. Let me take a snippy of another question, and probably we'll work it out, the ratios again. No, not this one, sorry. Right question. Okay, let's do this. Yeah, I think this is a good question. Look at this triangle now. Yeah. And I want you to give me, tan 50 degrees. What would that be? What over what? Lakshya says x on 18. Zara says x on 18. Yes, exactly. It is x on 18 is the right answer. Any questions so far? We're fine, right? We're okay at the moment. All right. Let's do another one. And I'm taking another snippy now. All right, here you go. Get ready. And can you give me sine 41 degrees, cos 41 degrees, and tan 41 degrees? I need sine 41 degrees, cos 41 degrees, and tan 41 degrees. Go for it. All right, I'm starting to get answers now. Come on, come on. Give it a go. All right, let's do this. Let's do this. Let's do this. So remember, I said sine 41 degrees. So I'm after this. I'll change the color. I'm after this. That's my angle, 41 degrees, right? What is hypotenuse? H. What is opposite? That's opposite. And this becomes adjacent. So first thing is that you need to identify your O, A, and H. Then it's easy, right? I'm just after sine 41. So I need sine 41 degrees is what? So opposite over hypotenuse. Opposite is 32, 49. So 32 over 49. And you simply work cos 41 is so ca adjacent over 49. The ca. And the tan is toa 32 over 7. Now let's change the direction and see how opposites and adjacents change. So now if I just paste the same image here and ask you, can you give me sine alpha? I'm talking about this angle now. What is sine alpha? Vikyat, we're just doing that. Concentrate. You'll be fine. Don't worry. What is sine alpha now? 37 on 49. Correct. How does that work? Now, whenever my angle changes, my initial angle was 41. Now I'm gone up to alpha. So I need to rework on my hypotenuse. Hypotenuse anyway remains. I need to rework on the opposites and the adjacents. What is opposite? Always draw a line pointing towards the opposite side, and you'll come to know which one is an opposite side to the angle that you're dealing with. So this is opposite. Simple. And hence, the remaining side becomes adjacent. So, SOH, so which is opposite over hypotenuse. So this becomes 37 over 49. Simple. Good, good. Kinetic, I think they're right answers. Okay, can you tell me, all of you, tan alpha, please? Tan alpha. Go for it. Give me tan alpha. Thirty-seven on 32 is the right answer. Good job. 37. What is tan? Soka toa. Opposite over adjacent, which is opposite is 37 over adjacent, which is 32. Finish. Is this clear? Everyone, today. Good. It's 9:59, one more minute to go. I think I will rest my session to peace here today because we need to deep dive a lot more moving forward into the unknown angles and unknown sides as we progress further down the track. Thank you very much for your time, and I will see your lovely faces back next Sunday. Enjoy your remaining long weekend. Have a good one.